My name is Hasini and this presentation is about an experiment to create models of energy usage of appliances in a low energy house and predict the energy consumption using environmental variables. The first slide is about the correlation between the variables. The given set of data are temperature and humidity of two rooms, also pressure as the environment variable and Y as its interest of variable, which is the energy consumption of the appliances. In the second slide, you can see we have generated the correlation between selected 450 environmental variables and the interest of variables. As per the above table, we have received positive correlation and one negative correlation between x and y variables. Correlation should be -1 to +1, and if the correlation is closer to -1 to +1, so can consider as a wrong relationship. X1, X4 and X5 are negative and showing a good correlation compared to the X2 and X3. Between X1 and X5, X1 has a weaker correlation than X5. As assumption, positive correlation showing higher temperature will increase the energy consumption, and the negative correlation indicating higher humidity might lower the energy use. The third slide is about data distribution, and here I have visualized the data distribution using histograms. As you can see, X4, X5 have negative skewness and X2 and X3 have kind of normal distribution. In this slide, there are scatter plots. Outcome have been displayed, and scatter plots also have a similar distribution like histograms. Box plots are very important type of plot type to find out the data set has outer layers, meaning the data not included within the specific range. According to the box plots, X1 and X5 have many outer layers. Because of that, we can decide which data set should be removed before we go to the next task. Correlation of X1 is weaker than X5, so we are removing X1 from our data set. In this slide, you can see the data transformation method that we use to transform the data to lower values. In here, we are using only 4 variables plus y. The method we use is minimum maximum transformation, which is called as linear feature scaling. We have generated skewness between x1 and y values and also visualize the histograms as well. So all the histograms in between the 0 to 1 value and also x2 and x3 showing a normal distribution. In this slide, we are talking about the importance of variables. When predicting y variable of interest, most important variables are temperature variable and humidity variable, because temperature and humidity directly affect the energy consumption level in a house. In this assignment, we use ordered weighted averaging OWA and WPM as the fitting models. These models include weight parameters, which supports to understand the specific contribution of each variable for predicting y using previous data. In task 3, we use 3 different fitting models, OWA, WPM, and WAM. According to the statistical table, all the Pearson correlation are between -1 and +1 in the table. RMSE is the average difference between each prediction and the output. If the RMSE is showing a lower value in the fitting model, it is a positive sign to use that model. In our experiment, OWA has a lower RMSE compared to the other fitting models. While generating OWA, it automatically shows the weighted parameters. As per the table, most of the weights parameters are 0. In this slide, we are going to predict the energy consumption for a given set of variables. Using error measure calculation, MAE, we receive the predicted value as 59, which is much closer to the predicted value. Therefore, the output is reasonable and accurate. The conditions for low energy use. So low temperature and humidity indoor environment requires less heating, leading to lower energy consumption. As a summary of the presentation, energy consumption prediction models can provide actionable insight for reducing energy usage in low energy homes. Thank you.